before, prior to this one coming up, because my hand is down. I have never seen an eclipse. When have you seen? Keep your hand up if you've seen multiple. If you've gone and seen multiple eclipses. Oh, snaps. Applause to you for seeing more than one eclipse. Because I have never traveled to see one. They don't really come around in Florida that often, so I've never really seen one. So I'm beyond excited for this. We don't have to travel. That's the coolest part.
It's very rare. It's going to be over 100 years before there will be another total eclipse here in India.
100 years?
140, something like that. Yeah.
100, 140. What does it matter?
It doesn't matter to me.
No, honestly, it doesn't matter to me. I think that's what was so interesting reading this book too. Was we have an example, and I guess we're getting into it. Was the example of the researchers realizing, oh, I'm not going to be able to test this theory, this hypothesis in my lifetime. I have to plan this out and hope that somebody else reads my notes, agrees with me, and then goes out, travels, and actually tests it at the next one.
There are areas of research to this day that look like that. People who do planetary astronomy based on things like the Voyager mission or missions to Mars, to Jupiter, to the outer planets. You get 2 per career because they take that long to plan, build, launch, and travel to the outer solar system. So if you're lucky, the timing is just right. You come in, starting grad school just as something is at a critical juncture, you might get 3 in a career, but most people only get 2.
Does that make you feel better about your experiments?
Absolutely, it does. We can maybe talk about this later, but I made a change out of astrophysics and into solid state physics in graduate school exactly because I became afraid of that kind of very big science phenomenon. I wanted something that had more personal control.
Yeah.
Bit of a control freak. I mean, that's just what it is.
Oh, for sure. That's terrifying. Before we get too into it, because I'm already into it, I'm so excited. I cannot even tell you guys. I'm so excited. I have so many questions. But before we get into it, I do want to let you give you a chance to introduce yourself to everybody, talk about what you do, and maybe give us a little tidbit about the book that you found most interesting.
Okay, sure. So I'm Andy Gallagher. I'm a professor at what is until July 1st, IUPUI. We will become, July 1st, we will become IU Indianapolis, with Purdue as neighbors, but not as family.
Neighbors is not family. I want that on a t-shirt.
Exactly. But I'm in the physics department. I started here in 1995, moved here from Maryland, where I've been working at a national lab. And I've been here ever since. As I was mentioning, my research originally I had been planning to do astronomy in college. In grad school, I made a change to a now called condensed matter physics, studying magnetic materials. I worked in magnetic materials for my PhD, moved down to the National Institute for Standards and Technology, where I was doing magnetic microscopy. And then from there, I came to IUPUI in 1995. Since then, I sort of gave up my lab research and have now been doing research into how students learn physics and how best to optimize the educational system. Yeah. And as far as the book goes, I think I was really interested in some of the parts about some of those historical experiments that were done to the first verifications of Einstein's general relativity were based on observations of eclipses, and there have been other experiments as well. And the whole thread connected with the general relativity and study of gravity, which is still an ongoing thing. We still don't understand gravity as deeply as we really wish we could. We understand electricity and magnetism and even some of the nuclear forces much better than we really understand gravity. So there are people in my department, and there are people in other places around the world still trying to understand how gravity works in a very fundamental way.
Do you know if any experiments are planned for this upcoming eclipse?
You know, I'm sure there are experiments associated with the eclipse. I don't know that there are any exact flavor associated with the eclipse. That level of general relativity is very well understood. The parts of gravity that are not understood are the parts that happen in very small length scales. So this is something that physicists do. We divide the universe up into scale.
Okay.
So the universe is, a galactic scale, or hundreds of millions of light years scale. Then there's sort of a planetary scale, where light travels in minutes to hours. Then you get this sort of moon-sized scale, where things are a meter across, and it takes light nanoseconds to travel across the moon. Then you get down to microscopic scales, atomic scale, nuclear scale, subnuclear scale. And we understand gravity from the whole universal scale pretty much down to sort of moon-sized scale. But if you get down to less than a millimeter scale, you have very little data about how gravity really works. At great scales, less than 10 millimeter fraction of a millimeter.
That's why. I just assumed all was the same. I agree so much.
We might hope it does, but we want data.
Yes.
You don't take anything for granted. Just because you say this works at every length from 100 billion miles down to a meter is not evidence that it works at a millimeter scale. You have to do this study. And they're very hard experiments to do.
I can imagine. How long did it take us to understand atomic mass even?
Oh,
And prove that?
I mean, in some sense, it took thousands of years, because the word atom is a Greek word, essentially meaning indivisible. The idea of an atom in ancient Greece was that you could take a piece of wood and cut it in half, and you could cut that half in half, you could keep cutting it down, but at some point you would get to some little thing that you couldn't cut anymore. And that is the idea of an atom at that time. But the idea of atoms, the way they get applied in chemistry, and how that's related to what stuff is made of, was really not even 100% certain right up to about 1900. And actually, another thing that Einstein did in one of his papers that he published in 1905 had to do with evidence that substances, everything that we know, is made up of those little particles that we call atoms.
Does it surprise you how much of, we learn a lot about the history, we really learn a lot about the history of astronomy and astrophysics. And does it surprise you how much of that, how accurate some of that was?
Absolutely. It's astonishing.
I could barely calculate a tip with my phone calculator. And they're calculating the size of the moon?
Yes, with chalk on a slate. A lot of the mathematics that we know, the mathematics that still bothers modern people in high school, geometry and algebra. Geometry is 2,000 years old, and algebra is about 800 years old, something like that. I don't remember. But from ancient Greece and from sort of Middle Ages, Middle East, where algebra was developed.
That was something that the book touched on. Is how much of math and astronomy was developed in the Middle East, but we don't know any of those researchers.
That's true. It's not actually well known, and he actually missed an opportunity to say something there. He says that algebra comes from the Middle East. What he didn't say is it's actually named after a person, Al-Jabbar.
Oh my God.
Yes, the word algebra is essentially derived from somebody's name, from mathematician, from the
Should stop working.
yeah, yeah, we just kind of skimmed over that, some editor, red line,
Oh my gosh. And I mean, do you think that's pervasive in other areas of physics and math as it's taught today? That we're missing?
We're missing some of the history, absolutely. Teaching science and teaching math, there's so much to learn. And there's a lot of difficulty, and a lot of people struggle with things, and there's a temptation to always say, all right, we're just going to do the absolute essentials, and we're going to leave out all the peripheral stuff.
Yeah.
And that peripheral stuff often is the history or the philosophy of the subject. And on the one hand, I understand completely the need to do that, because your students need to have a certain skill set before they move on to the next year.
Yeah.
And you don't want to spend time on things that aren't going to be on that test or aren't foundational to the next level subject. On the other hand, it often cuts out the opportunity to make the human connection. And for many students, I think they would be more inclined to learn if they knew some of the people, they knew some of the personalities involved, they knew some of the struggles that those people went through. I mean, every imaginable difficulty that you can imagine befalling a person in modern America has befallen some scientist or mathematician in the past. There were particle physicists that contributed huge amounts to our understanding of that subnuclear structure I was referring to in the 60s and 70s and 80s, who grew up in Japan in the aftermath of World War II or during World War II. People whose homes were bombed during World War II, who wound up becoming eminent scientists, Nobel laureates.
I had no idea.
Yeah. Yang is one of those. And
you're right, the history of it.
People like James Clerk Maxwell, who's a famous Scottish theoretical physicist who's responsible really for our understanding of how magnetism and electricity are related. If you see physics majors walking around with T-shirts with equations on them, those are usually Maxwell's equations.
Good to know.
Maxwell died in his mid-40s of a blood disease that would easily be treatable now.
Oh, gosh.
And he had so much more he could have done. He contributed tremendous amounts to thermodynamics, to astronomy, to electricity and magnetism, to other areas of physics, all between his teens and his early 40s.
Oh, my gosh. Yeah. That was part of why I picked this book, for the eclipse. I mean, we could have gone heavy in the physics. We did I want to say about a year ago, we did a quantum mechanics book that, let me tell you something, took me a long time to get through. And I still don't think I understand it very well. But
But this one's very history-based, which I liked.
Me too. And it was so important to me to put not only the eclipse, but to put the science that we do it now and today. And as we know it, as is taught, just didactic in, grade school, putting it in the context of there was somebody who sat and thought about, and I love that you point out the importance of teaching the history with the science, because I think a lot of students, when you're learning about something like this, you're learning about, how they figured out the size of the moon or how they understood orbits. You think they just figured it, they looked at it and they had the answer immediately. And if I don't have the answer immediately, I'm not smart.
Yeah.
You're talking about you're in your 40s, 50s, 60s on taking years, sometimes decades to test ideas and hypotheses to understand and come to that conclusion. But it's taught so just snap, fact. You don't get that.
That's true. And that's actually something that I often have to watch out for when I'm teaching. You practice. I write up notes the night before. I think about what I'm going to do. I have a whole plan. And then I go into the classroom and I'm presenting it, whether I'm on the screen or on a blackboard or a whiteboard or whatever.
Yeah.
And students sometimes will say, I'm just not that smart. And I'm like, look, I'm not that smart either. I can't just do that off the top of my head.
Yeah,
I had to plan it. Takes me 3 hours to plan a 1-hour lecture.
100%.
And I've got to write it up and plan it out, and things get cut.
Yeah.
There's a whole editing process to developing a lecture.
100%.
And it winds up coming out as if, oh yeah, I can just say that.
Yeah.
No, I can't just say that.
Yeah.
That required figuring out.
Oh, 100%.
And it's recorded, and you can review it.
Yeah.
So, you can learn from this, but you don't have to expect to be able to just do it at
Yeah.
the pace that I'm doing it.
Yeah.
And then similarly, students sometimes will say, oh, I couldn't do the homework. Well, what do you mean you couldn't do the homework?
Yeah.
Well, I spent over an hour working on it. I couldn't do it. I only got 2 of the problems done. I'm like, look, problems take a long time. You're not supposed to be able to just write out the homework in an hour. It's supposed to take you several hours for several days. That's why it's only once a week.
Yeah.
And students say, well, I don't know if I have the patience to do that.
Yeah.
I'm like, well, look, you're an engineering major. You want to go, who do you want to work for? SpaceX? Boeing? GM?
Yeah.
How long do you think it takes to design a jet plane?
I don't even want to
I'll tell you
know.
how long. It takes several thousand people 5 years to design a plane.
Yeah.
It takes several hundred people a few years just to design a car engine that goes in a Ford.
Yeah.
You don't just design a new engine from scratch. That's why these things get moved from model year to model year to model year. You can change the tail lights in a few weeks. You can't change the engine in a few weeks.
Oh, no, even a few years, a few decades. Yeah. And I think that's why I enjoyed this book so much, was that it really humanized so much of what I think me and a lot of people learn as just bullet point truths of the field, when in reality it was potentially hundreds of years of trying to figure it. I mean, how long, one of the things that surprised me was how long and how many iterations it took them to understand the orbits. They just said, yeah, it kind of goes back and forth and squiggles over there, but otherwise,
Right.
know.
Yep. Yeah. The old geocentric model of the solar system lasted for a couple thousand years. And the reason it lasted that long was because it actually worked very well. You could predict a lot of things with that. There were some difficulties, but nothing that couldn't be overcome with ingenuity. And then when we started proposing first, a heliocentric model with Copernicus and Galileo and, that period, there were problems with that model too. And there are things that it did not explain as well as the old model. So there was really a fight. And that fight lasted for a while.
Shocking.
Yeah.
Shocking how long it lasted and how long it took. And I want to keep talking about this point, but I want to take this to a turn and talk, because I would like to hear some other thoughts on this. And so the scientific method, we have all learned it in school. We're all pretty familiar with it. Testing, gathering evidence, testing an idea, presenting that evidence, and then working within your field, others in your field, to envelop that in our understanding of the world, to help improve our understanding of the world. When we look at the heliocentric model, it wasn't just one experiment. It took a lot of experiments. And even with evidence, there's also the social aspect of people saying, well, no, that's not what I learned, so that can't be right. And I mean, it was a story of so long ago, but I think we have seen that play out in the public sphere today. And we see it all the time in the modern era. And so I want to pose this question to you, but I also want to pose this question kind of to everybody. Is evidence enough when you have what is considered, something, you have been taught something as a fact? We know that presenting somebody with data to the contrary doesn't change their mind. And we've seen that in history, we see that now. So is just having evidence enough to change someone's mind, or do we need to have lots of evidence? Do we need to convince somebody really important in the field? Do we need to put out press releases and try to get public shift to happen to embrace these new ideas so that we can actually embrace new dogma, in fields? That's something that I was thinking about when reading this book and reading this section of the book, and something that I would like to pose to you all, because I would love to hear your thoughts, because it's something that modern science is struggling with now. So I'd love to give you like 5 minutes to chat about it, and then we'll come back, and I'd love to hear what you think we can do. So yeah, I don't know if you're familiar. Turning Talks they'll talk about it. We'll continue to talk about it on our live stream, because it'll be recorded.
Sure.
And then we'll come back and hear some thoughts, because I could not help but think about that situation in a modern context, what we've seen with vaccines, what we see with, all of the new information about COVID that is so public. And it's just some of it, as the COVID research was coming out, it was challenging the ideas that we had, maybe a few months or a few years
weeks
earlier.
Or months earlier, yeah.
How do you say science is evidence-based, science is so concrete, but it's not?
Well, it is evidence-based, but it is not static. And that's actually one of the keys.
Yeah.
That's one of the strong points of science, is that it isn't dogma. It isn't something that once you've said it, it has to remain true.
Yeah, you're right.
You have to be open to change, and the newer an idea is, the more open to change it becomes. And there is a sort of a hierarchy. You can say, all right, this is an idea that's only been tested 2 or 3 times, and just in the last few months, we could get rid of this on a moment's notice.
Yeah.
Something that's been around for 5 or 10 or 15 years and has quite a bit of evidence. Say, well, okay, that's a pretty strong idea, but it's not set in stone. A good wealth of new information that seems to point in a different direction has to be taken seriously and examined further.
Okay.
Something that's been around for 500 years and has been tested hundreds of thousands, millions of times, on which common everyday technology is based.
Yeah.
That's something that, it's not dogma, but it requires an extraordinary amount of evidence to want to revisit.
That's fair.
And that's one of those things, you just kind of have to say the more extraordinary a claim, the more extraordinary the evidence needs to be to support it.
Yeah.
And
makes sense. So what do you think about, for example, what we saw with the planet Vulcan, where we just kind of took the story and we tweaked it 7 billion different ways every couple months?
Right. So the idea there was that the orbit of Mercury was just a little bit off from what you could calculate using Newton's laws that worked perfectly for all the other planets.
Yeah.
And the question was, why is that? What is causing that very slight, hard to observe, but definitely observable, real change in Mercury's orbit? And one of the possibilities was that there was this extra planet that had never been observed because it's so close to the sun that it's just always buried in the glare. But which the technology was getting close to being able to reveal if you just knew exactly where to look. And, based on the orbit of Mercury, you could try to predict, it must be here now, it must be there now. And people would sometimes, it's a very hard observation to make. So sometimes you look, and it's like, if you're outside, walking with friends, and somebody says, hey, I think I see an eagle.
Yeah.
It's very far away, though. Can you see it? And they're saying, oh, no, it's a little to your right. It's up there. You kind of squint and say, well, I think so. I don't know. There's a little dot there. I'm not sure. And then you're like cleaning your glasses.
Yeah,
maybe,
you're cupping your
that's
eyes.
What it is, right? You're trying to shade your eyes, whatever. So there can be observations that are hard to make,
Okay.
But it's possible, and you're working hard to do it.
Yeah.
And sometimes you say, yeah, 3 of us here, and we all agree, yeah, it's definitely a thing. And
Yeah.
we watched it for a little while, and it moved in a way that made us think, yeah, that's probably really is a bald eagle.
Yeah.
But then there are other times that 2 out of 3 people go, nope, I never saw it.
Yeah. It was just so interesting to see how no one was willing to. It just kind of just kept getting dragged along,
Right.
and
It was a good working hypothesis,
Yeah.
and it's just as hard to disprove as it is to prove.
oh yeah,
So, you know,
have evidence either
you
way.
keep working at it, and if you don't have a better idea,
yeah,
you might as well keep working on that one. There were some other ideas, which he didn't get into, by the way. Another thing that,
Ooh.
you know, there's always stuff when you write a book that you want to
Gotta
sell
go.
more than 5 copies. You can't put in everything that anyone knows.
That's fair.
So
That's
one
fair.
of the other things that he did mention is that there was another possible explanation that had to do with the sun not being perfectly spherical. There's an oblateness, it's sort of a flattened shape that's not quite spherical. That could also have affected the
Oh.
orbit of Mercury.
Now that's an interesting idea.
Yeah. But you know, again, people were trying to do calculations and say, well, how non-spherical would it have to be? Could we observe that? You know,
Yeah.
and that wasn't really working out either.
Yeah.
So this is what happens when there's a question in science: is people brainstorm, they throw out ideas. Well, maybe it's this, maybe it's this, maybe it's this. If we can't explain it, let's try some more outlandish ideas. In the end, the thing that really explained the orbit of Mercury
Yeah.
was the general theory of relativity, which by anyone's standards is still pretty outlandish. I mean, this is
I
a
understand why it took a
hard
long time.
idea to swallow.
Yeah.
That space and time are not the same for every observer. That it depends on whether you're moving. It depends on whether you're accelerating. It depends on whether you're in a gravitational field. That the gravitational field that causes the Earth to orbit the sun also is reshaping space, and that light would travel differently through the space just because the sun and Earth
Oh my God.
are there in orbit.
Yeah.
You know, it's extraordinary, and it affects time as well as space. It's so confusing.
Beyond.
And mathematically, you can't just sit down and say, "Oh, look, you just add 3 and 5 together and look at
Yeah.
this," you know, and there it is. It's this hugely complicated thing. I don't know the mathematics to do general relativity well enough for me to do it.
Yeah. I barely
I just
understand
never
the
went into
concept.
that area.
Yeah. Well, is that its own? I'm assuming that's its own field of. I mean, it's got to
Well,
be its own thing.
So it's a major subfield of physics,
Okay.
trying to understand general relativity,
Yeah.
for sure. There are people who specialize in this area.
I bet.
It's not a very big one, actually.
Really?
Yeah, there's way more people working in quantum field theory and in various
Oh.
aspects of quantum theory and condensed matter physics,
I wouldn't have guessed
semiconductor physics, plasma physics, astrophysics,
Ooh.
cosmology, all of these things. People who are truly focused on general relativity are not a huge group. But
Okay.
you know, they do their thing, and it's great, and they help explain that to the rest of us.
Yeah. Now, can I ask potentially a dumb question?
Yeah, of course.
Is relativity only observed on the planetary scale?
No, actually, it's not. We
Okay.
have tabletop size experiments that
What?
can be done. I have seen a few years ago, so not a tabletop one,
Yeah.
but you can take an atomic clock, which you may think of as some amazing piece of technology, but let me tell you something. You can buy an atomic clock on eBay for probably less than
eBay.
$10,000. You know, less than a car, less than the cost of a used car.
Wow.
Even. So I saw a report a few years ago of an experiment that was done with college students where they bought an atomic clock they bought 2 atomic clocks off eBay,
Oh, wow.
and they kept one of them This was at the University of Colorado. And they kept one of them on campus, and they took the other one up to the top of Pikes Peak. And they got like the park rangers people to let them stick this thing in the ranger station in Pikes Peak, and they could observe the difference in the rate at which the atomic clocks ran
that's so cool.
between Denver and Pikes Peak.
Oh, that's so cool.
Just because the atomic clock, even for $10,000, it's accurate enough to measure the effects of general relativity over the scale of a kilometer or something in altitude.
That's wild. Also, kudos. I hope they went on to grad school.
Oh yeah, I'm sure they did.
Kudos to those
At least
kids.
many of them. There's also an experiment, famous experiment done, I think in the 1960s, where they used a nuclear decay. I won't get into all the details, but it's one of those things where a gamma ray is emitted from one place and then can be observed very accurately at another place.
Okay.
And they did it in a stairwell at Harvard, just like 2 or 3 stories in a building. And they could tell the difference in the observed gamma rays over a few stories.
That's
due again to general relativity.
Oh my gosh, I didn't realize that was something that was observed. I've only ever heard it explained on a planetary scale.
Yeah.
Had no idea it worked on a room and
Yes,
table.
on a building size experiment,
Oh my
and then on a sort of a 1 hour drive size experiment.
Yeah. Yeah, I feel like molecular relativity might be too. That might be wild.
Okay, so special relativity, which is
Okay.
not the same as general relativity,
okay.
but
Oh, well,
has
yeah.
some overlapping phenomena. There are observable consequences in atomic spectrum.
What?
If you look at something like the light emitted from, neon lights or other discharge tubes, just the spectrum of hydrogen, there are very, very small, what's called fine structure effects
Oh my gosh.
that can be
That's wild. That's crazy.
probably not in hydrogen, actually. Certainly in uranium. The orbit of electrons in the so-called inner shells, if you remember that model of nuclei, there are relativistic effects going on there.
Like I only ever thought about it from a planetary scale. The fact that it exists and is observable at that level is beyond my comprehension. That is so cool. I think we're gonna go ahead and come back.
Yep. Okay.
It's been a couple minutes, but been a little longer. Sorry. I got excited. I got distracted by relativity, which, hey, don't we all? Doesn't it happen to the best of us?
Absolutely. Yes.
But I would love to know what you all thought, or what you guys maybe talked about. I'd just love to know what you think about this idea of science. Obviously, is not infallible, and you made a good point. The beauty of it is that it changes, and that it is not static, and that is the benefit of the field.
Mm-hmm.
But there's so much that we're taught of as this is fact. And if you see a piece of evidence contrary to what you believe is fact, you're not inclined to accept it and incorporate it into your schema. And so I'd love to know, I think this is a modern problem. And so I would love to know what your thoughts are on this. I mean, to me, this ties into misinformation and this science, this truth behind science and believability of science that we're experiencing today. Some fields more than others. I feel like people...
I think you just need to yell at somebody. Who wants the microphone?
Yeah.
Who wants to talk
Yeah.
about what they think of evidence?
I think that there's a certain number of people who are disinterested in evidence or theories, and they want to garner attention, and they do everything they do for clicks and likes. But I think most people, I still have faith in human nature, and I think most people will consider the evidence and the theory and think about whether the theory fits the evidence, and when a new piece of evidence comes along, does the theory still fit the evidence, or do we need to modify the theory? I think, most people are willing to consider when new data comes along to rethink a little. But, there's always going to be some that just want to do the look at me.
Yeah. Well, and you made a good point too in our discussion. It's so hard with, longer theories, like longer lasting, 500 years versus 5 years. It's a different threshold.
Mm-hmm.
It's something I hadn't really thought about. Yeah. Yesterday's experiment, I can throw that out.
Yeah.
Probably will.
But you could probably feel that way just about things that you've learned. I mean,
Yeah.
something that you read about once in a magazine, somebody comes and says, no, that's not really true. You're like, well, yeah, I guess I could give that up.
Yeah.
But
Yeah.
something that you've seen dozens of times from dozens of sources over a period of years, you're like, no, you can't just tell me that's wrong
Yeah.
without much evidence. I've
Yeah.
heard that too many times from too many different sources.
Yeah, that's true. That's fair. And it's a double-edged sword. In some instances, good. We resist the change. We ask for more. And in some instances, like, the geocentric model, I mean, we know it correct now, but I couldn't imagine at the time you do think that's so beyond.
Mm-hmm. And it made sense.
Yeah,
I mean,
at the time.
Just like the Earth does in fact look flat, especially, in some parts of the world, it
Yeah.
looks particularly flat.
Yeah.
But and you never have any further experience of the world. It's an easy idea to just adopt.
100%.
If you look at the sky at night, you see things going around, and they come up over there, and they go down over there, and they come up again on the other side the next day.
Yeah.
It starts to make sense that everything is going around where you are.
Yeah.
It's particularly, this is something that I think we may not appreciate as much, because if you live here today in Indianapolis, you don't see the sky very much.
No.
If you lived in ancient Greece,
Oh, yeah.
where there, at a time where there were no streetlights, the weather was beautiful and clear, Mediterranean weather, you saw a glorious sky night after night after night.
Oh.
And you could see all those things, all those stars in brilliant color.
I bet it was beautiful.
Most people these days don't even think of the stars as being all different colors. You sort of think, yeah, I guess Mars is reddish.
Yeah.
And
Yeah.
you might have noticed some stars seem a little bluer and some stars seem a little redder. But in fact, the colors are very dramatic. And,
Really?
And if you get beautiful, clear nights, dry, dry air, if you can get up in the mountains especially,
Yeah.
it's just extraordinary.
Oh my gosh. Yeah.
If you've never done it, the second best thing to a total solar eclipse is
Okay.
just getting to someplace really dark and really clear
Yeah.
and seeing what that night sky looks like.
Oh my God. I can't, you know what? I hadn't even thought about just looking up at the sky. Historically, completely different experience.
Mm-hmm.
Completely.
Yeah. I bet people here have some experiences they could relate. What was the best sky they
Yeah.
ever saw? What was the best sky you think you ever saw?
Probably up in Alaska.
Okay, yeah.
Yeah. Although I wish, if anyone's seen the Aurora Borealis, I need you to tell me where and how amazing it was, because I want to travel so bad. I got an itch and I need to scratch it with an Aurora.
I would love to do that too. I have seen it, but only out an airplane window. And it was just green, and glowing on the horizon. But, I was on an international flight that went up over Northern Europe and Greenland and Iceland
Nice.
before coming back down,
Yeah.
across Canada and into the East Coast.
Yeah.
And I happened to have a port side window. And for several hours, every time I looked out the window, it was just green.
Oh,
like
that's
this
awesome.
amazing green curtain on the horizon, on the northern horizon.
That is so cool. Yeah. That's got to be your coolest sky, best
That's,
sky
well, that was definitely a cool thing to see.
phenomena.
I think the best sky, just in terms of stars, probably was in the Caribbean once.
Ooh, the
Although,
Caribbean.
no, one other. So I went to Hawaii, and we went up to there's a visitor center associated with the big observatory on Mauna Kea.
Oh,
So
yeah.
it's at 10,000 feet. There are zero lights of any kind
Oh, wow.
up there, and it is clear and cold. I got to tell you, this was a wonderful scientific experience from an ecological as well as an astronomical point of view.
Yeah.
Because we started the evening at sea level,
Oh, wow.
had dinner with palm trees around and the Pacific Ocean right there by the side of the restaurant, got in the car and started driving uphill. And first you go through, the sort of rainforest, and then you get up into the cloud forest, and then you get up into sort of high desert area, and then you get up into the mountains, and it's freezing. It's literally in the 30s.
What? I had no idea.
And the sky is unbelievably dark, and the stars are unbelievably bright.
That's so cool.
And there was a little extra bonus to that,
More?
which is that Hawaii is far enough south that you can see Alpha Centauri, the closest star to us
Oh, wow.
in the galaxy. You can't see Alpha Centauri from the northern hemisphere from here.
Yeah.
It's in the southern hemisphere of
Yeah.
the sky. So you get to Hawaii, you can see it. It's close to the horizon.
That's awesome.
But you really need to go to the southern hemisphere for it to be up high overhead.
Yeah. Oh my God. So that's got to be number one.
So it's just a dot. It's a boring little star to see, but just knowing it, it's like, yeah, that's the one I've been reading about all my life. That's the closest star.
That's what makes it so cool.
Yeah.
And I think that's why the eclipse is going to be so cool for me. Because I mean, at least for me, because reading this book and I'm hyping myself up. I'm so ready for this.
If anybody in the room is considering missing the eclipse for any other reason than dense overcast, I'm begging you to rethink that decision. Because this thing is going to be a once in a lifetime. It is not just something that's cool to look at.
Yeah.
This is not like, oh, I saw a Ferrari on the highway today. This is going to be something truly awe-inspiring, amazing. You're going to see stuff that you can never see at any other time in your life.
Yeah. Well, and I mean, we get that impression through the book too. I mean, we see throughout the ages, not only the awe, but I mean, just the opportunity that it presents, not only for us and for the scientists to connect with the stars and to connect with their research and the planets, but we also get a little bit of a glimpse into how local populations who have predicted these. I mean, it's not just scientists who are tracking and predicting this, but there's cultural significance and even religious significance. There are strong religious ties to the eclipse that I had never considered, and how significant an event it is to just, they happen. We know they happen more frequently than every 100 and so years.
Oh, yeah.
But to just be able to go outside, set an alarm, go, okay, I'm going in the front yard. gonna go look at the, wild.
In Indianapolis, if you're really, really, really busy and you can only spare 15 minutes, you just go outside at a couple minutes before 3 p.m. and just commit to being outside until 3:10, 3:15. Just take 15, 20 minutes. But centered, the peak of the eclipse will be between 3:06 and 3:10. That's when it will be a total eclipse around here, and it will be astonishing. So if all you've got is from 3:05 to 3:11, take from 3:05 to 3:11 and get outside.
Yeah. No, that's got to be the take-home message. Because I've been preaching. I advise a group down in Bloomington, and I am harping on them. I'm like, get the glasses. Don't look at it. Don't look directly at it, like I did in 2017. Do not do that because you fully will singe your retinas. But just take the time. And I mean, some of them are college students. Oh, well, we had one in 2017. What's the big deal? You're once in a lifetime. There was one a few years ago.
Yeah, no, that was a partial eclipse.
Yeah.
And you asked earlier, who has seen an eclipse before?
Yeah.
But you didn't specify a total eclipse.
Ooh.
And here,
You're
this
so
is
right.
this is crucial.
Yeah.
Because a total eclipse is total. It's totally different.
Yeah.
There's absolutely no comparison
Yeah.
between a total eclipse and a partial eclipse.
Yeah.
The way I would put it, so the sun and the moon are about the same size in the sky. They're about the size of your thumb held at arm's length. That's
Okay.
about how big the sun is.
Yeah.
It's about how big the full moon is.
Yeah.
The brightness of that little bit of the sun is about 1 million times the brightness of the full moon.
What?
1 million. So here we're going to just do this is all the math we're going to do tonight.
Okay.
A partial eclipse that is 99.9% is still 1,000 times brighter than the full moon.
Oh, because not. Okay. Yes.
1,000
that math
times.
makes that's okay. Yes.
That really tells you, because when in 2017, here we had something like 60% or 70% or something. It's barely different than a sunny day.
Yeah.
It was barely, you could tell if you used the glasses, you could look at it
Yeah.
and tell something was going on.
Yeah.
But you couldn't just look around and say, oh, wow, it's totally different. It's not even like daytime.
Yeah.
This will be almost exactly like daytime
Yeah.
right up until, let's say, 3:02.
Yeah.
And then it will start to look really weird. And by 3:06, it will be darker than sunset.
Darker.
Darker than sunset. It won't be dark. You won't need a flashlight.
Yeah. Okay.
It'll be like twilight,
Yeah.
but there will be no direct sun on you. It'll be like the sun has just gone below the horizon.
That's wild.
And that will last for 4 minutes, and then it will come out again.
Yeah.
But during those 4 minutes, you will feel the temperature drop like many degrees.
4
10
minutes?
degrees. Oh, yes.
What?
You will be chilly.
Oh my God.
The birds will notice. The birds will stop singing.
I'd be nervous too.
That was actually a mistake that he made in the book. Oh my gosh. It's just, I'm a bit of a birder, so I got to call him out on this. He
Let's
says the
go.
birds will return to their nests. No, birds will not return to their nests. Birds use nests only for raising baby birds. Birds do not go sleep in nests every night. Birds just go roost on a branch somewhere.
Okay.
So birds will roost, birds will go to the trees and roost, and they will stop singing.
Yeah.
But there's no nesting involved. Nesting is for raising baby birds.
Oh my God. I had no idea.
So just gotta
Yeah.
give them a
Little
little
letter to the
little
editor.
whack for that. Yeah.
Yeah. A little. Oh my God. So, well, that's so interesting too. That to think that it's not just us, who are looking up at this as like an intelligent species, which a couple books ago we had a talk on, what is even an intelligent species? But I mean, animals are going to.
Animals are going to notice this. Absolutely. There are other things that are going to go on. Remember I said
Oh, no.
that the degree of darkness is going to be similar to twilight?
Yeah.
One of the effects that you can see is that if you look at the horizon, and Indianapolis is a perfect place to see this. They will not see this in the mountains of Colorado or wherever. But in Indianapolis, it will be really clear. There will be a ring of like sunrise, 360 degrees all the way around. You'll be able to see the horizon. It will be brighter at the horizon all the way around.
Oh, that.
You'll never see that under any other circumstances. And the lighting will be weird. You will see reds and greens will be washed out and blues will be extra bright. I'm told one of the things you should do is plan for the eclipse, wear some red and blue, or bring some red and blue with you, and so that you can see what that looks like during the eclipse.
Wait, is that because of you're only getting the corona?
It's partly because of the corona, yes. So you're getting a different section of the solar spectrum.
Yeah.
During most days, you're getting actually a lot of yellow and orange light. It's not because the sun is yellow and orange, it's because the atmosphere takes a lot of the blue and scatters it around. That's why the sky is blue, actually. The sun is yellowish for the same reason that the rest of the sky is bluish. Because you start with white light and split it up in that way.
Yeah.
But there's lots of other things you can see. Another thing to bring with you, if you're going to like just go out to a park, or you can be out in your own yard or whatever for the eclipse, bring a white sheet and a colander out of the kitchen.
Colander?
A colander, like you would drain pasta with. Because a colander is a thing with lots of little holes in it.
Yeah.
And if you hold it so that its shadow is on the white sheet, each little hole in your colander will produce its own little projection, its own little pinhole camera type view of the sun, and you will see that partial eclipse phase in a colander's worth of dots on this thing. And then
that'll be cool.
As you get to that 302, 303 section, you will start to see bands of shadow moving across your white sheet. And that's because essentially you're under a very bright but very tiny source that is the very crescent remaining of the sun. And what you're seeing is shadows that are equivalent. The best way I can explain them, the equivalent, is that if you look into a swimming pool on a sunny day, you see dark and light bands on the floor of the pool that come from the ripples on the surface. There are ripples in the surface of our atmosphere, changes in density of the air in our atmosphere as warm air rises and cool air settles and all of that stuff goes on. And that will produce that kind of shadowing that moves around. And you probably can't see it on the grass, but if you lay out a bed sheet on the ground, you can see it.
That's wild.
I've seen video of you can see it on the hood of a white car.
Oh, yeah. That's probably bring a sheet in your front yard or a white car. Oh my, the weather better be good because I'm going to be upset.
Oh, yeah. I'm going to be so upset if the weather is not good.
Yeah, it will be. Is somebody getting married? Nobody's allowed to get married on that day.
Nope.
And I want to know, as an event, I mean, I think there are a lot of people excited about it, obviously. What are they saying? Like 1 million people are coming to Indianapolis just to see this. People are excited about the eclipse, but I think some people see this as, it's only going to be exciting for children, and it's just kind of like an activity to like get children involved and engaged, which is awesome. And we want them to this. For some kids, this might be the moment where they go, oh my God, my life is going to be this.
Oh, yeah.
But is it really just an event for kids to be excited about?
Absolutely not. No, it is absolutely not. I mean, this is the best lightning storm, rainbow, amazing surf. Any time that you have seen anything in nature that you looked at and said, wow, this is going to be 10 times cooler than that, whatever it was.
Ooh, 10 times? I'm holding you to that.
Yeah.
Okay.
Easily.
Yeah. Well, I mean, considering that, we learned in the book about not only what they called corona files, the people who love solar eclipses and they travel to see them. I want to read this book about the psychology of people who are addicted to seeing the eclipse, because it is that cool, even though it is not that frequently occurring of an event. It is enough to form an addiction and have a psychologist specialize in it.
Apparently so, yes. I'm not sure whether it's a psychological or a sociological phenomenon, actually, because one of the appeals is when you go to an eclipse, particularly in a remote area. I mean, here you can come to Indianapolis, you can go to Dallas, Texas, you can go to Cleveland, you can go to Montreal. There's lots of big cities in the path of this eclipse.
Yeah.
But there are some eclipses that only occur over the middle of the Pacific Ocean. There are eclipses that only go across, a tiny slice of the South Pacific and hit a few islands.
Yeah.
There are eclipses that only go through the Australian outback. There are,
Darn, gotta make a
and
trip.
So, and in the book, he talks about that one. He had to go to the Faroe Islands. Do you know where the Faroe Islands are? Have you looked that up on a map?
I barely know where I am.
Oh my God. The Faroe Islands are like way north of Scotland, like way up in the North Atlantic. It's,
The dedication.
Yeah. And, you go to a place like that, and there's going to be a crowd of people that are only there for the same reason you are.
Yeah.
And that becomes a little community. And remember, he talks in the book about how, the weather was terrible, and most of the people there didn't even see it.
Yeah.
A few people did, but most people didn't. But then afterwards, they're all hanging around at dinner talking about, how amazing it was. And just even though they couldn't see the corona because it was overcast, it got dark and then it got light, and it was magical in its own way.
Yeah.
And it's a shared experience.
Yeah.
And that shared experience is also part of it. In fact, the people who are really big eclipse watchers that I've talked to, the real coronaphiles, one of the things that they say is see it with people. Even if if you can see it in your backyard, but you don't have any family at home, go visit your neighbors. Go see it with a few, even if you can only find 5 or 10 people to see it with.
Yeah.
Go see it with some other people so that you can share it and share that experience and have different people noticing different things.
Yeah.
Because it's very complicated. Lots will happen and it will be over in 4 minutes. So everybody will miss something.
Yeah.
And that's another reason why he says, don't try to take pictures. Don't get messing around with a camera.
Yeah.
My friend who is a major coronaphile who's gone all over the world to see these things, he's in the Pacific now on a boat to see this eclipse.
Oh my
Well, he's
God.
not there yet, but he will be on an ocean trip in the Pacific off the Mexican coast for this
my God.
one, because he doesn't want to risk the weather of Indianapolis and miss it.
I think a lot of us
But
can
he
relate.
said the first 2 eclipses he saw, he mostly missed because he was screwing around with his camera. And he just said, don't do it. Don't screw around with your camera. Don't try and get the best picture. Just enjoy it.
Yeah.
Then go see another one. Then you can start messing around with cameras.
Yeah. Oh, good advice. Honestly, solid advice. And he makes a good point too. People will be taking pictures. There are professionals who that's their job.
Right.
Let them do it.
And if you're tempted, if you think you might want to try to take pictures of the eclipse, here's my advice. Between now and then, go try and take a picture of the moon.
Ooh, yeah.
Because it's about the same size. And if you take a picture of the moon with your cell phone, even with the best zoom lens available on the best cell phone available, it's going to be like that big.
Yeah.
It's going to be a dot.
Yeah.
You're barely going to recognize it as the moon, and it's going to be really hard to focus on because your camera doesn't want to focus on that. It wants to focus on stuff that it recognizes.
Yeah.
Smartphones have a tremendous amount of software built in associated with autofocusing.
Oh, yeah.
And it's very hard to turn off.
Yeah. Yeah.
And so most people cannot get a good picture of the moon
Yeah.
even with a reasonably good DSLR. Unless you own, $1,000 plus zoom lens and a good tripod, not a cheap tripod, a really good tripod that costs a couple $100, you're not going to get a very good picture of the moon.
Yeah.
Right? I've got a decent picture of the moon that I took with my best lens on my best tripod. And even now, you look at it, it's like, that's clearly the moon. It's a decent picture of the moon, but, I can find a better one in any magazine. They're in ads.
Oh, in Google. Yeah.
Yeah, just Google pictures of the moon. You'll get a much better picture of the moon.
Yeah. No.
Same with the solar eclipse. Just Google it the next day. You'll get 1,000 pictures.
Exactly. Google it the next day. Enjoy it in the moment.
Yep.
Enjoy the moment. And yeah, you know what? I was going to go out and I was going to harass my neighbors anyway. So now you've given me more encouragement to harass them
Yes,
louder.
go harass your neighbors. Yeah, get them out.
Yeah.
Get them out of the house.
Oh, I will.
If they're not standing on the front porch by 3 o'clock, you got to ring the bell.
Oh, I'm banging pots and pans.
Yeah.
This is a West Side neighborhood. We're banging the pans. And before, I don't want to get too carried away and take up all our time. So we'd love to open it up for Q&A. If anybody has any questions about, I mean, there's so much that this book touches on that you know, we didn't get the chance to talk about. So if there's any like aspect of this book that you want to talk about, that you want to bring up that we haven't, if you're just like super jazzed, I'm super jazzed, and I seem to be the only one in my immediate circle. So I'm glad I found camaraderie with you guys, because I've been dubbed crazy.
Anyway, there we go. Yeah.
And I'm not crazy. Well, maybe I am.
Thank you, Rufus.
Just
So in the book, the author mentions that we have a limited amount of time, how many, until the Earth no longer experiences eclipses. And what is the first, sorry, Rufus. What is the first sign on Earth that I doubt humans will still be around by then, but if we are, what is the first sign on Earth that we can tell that there's going to be a distancing of the planets?
Oh no.
So that's a really interesting question. It's because it's going to happen very gradually. I mean, I think
Sorry. Okay, we're good.
feedback is still a thing.
Yeah.
Even in the book, I think he quotes the number that the moon is moving away from the Earth at 1.5 inches per year,
That freaked me out.
right? Like your fingernails grow like that fast. And the moon is currently about 250,000 miles away. So 250,000, there's how many inches in a mile? About 50,000, 60,000-ish.
Yeah.
That's 60,000. So 60,000 times 250,000, that's the percentage kind of difference that the moon is moving away. So it's not happening anytime soon.
Good.
And,
Excellent.
And it will happen so slowly, like no one person in their lifetime will notice a difference.
Oh.
What will happen, let's assume that humanity does super well. Like we can all be,
Let's play pretend.
we can all be a little pessimistic once in a while. You know, you look at the news and you think, everything's going in a handbasket to you know where, and you know, we just don't want to deal with the future. But there's a possibility that humanity will actually last for tens of millions of years, hundreds of millions of years, and we'll keep wonderful scientific records for the whole time. It's unlikely, but you know, let's assume it could happen.
It could.
So what will happen is people in the far future will be saying, you know what, the longest eclipse that's going to happen in the next 20 years is going to have a totality of only 3.7 minutes. Whereas I looked back, and way back in the 20th century when they first invented computers and sailboats, then at that time, eclipses could last as many as 6 minutes long. And, you know, now it's down to 3.5. You know, the moon has been moving away for so long that our eclipses are only half as good now as they were then. I really, you know, pity the people another 100 million years from now who are going to miss this kind of thing entirely.
Yeah.
Who knows?
I didn't want to mention it because it sent me into a spiral.
Yeah.
So I'm glad you brought it up. I don't know why 1.5 inches a year seemed astronomically large. For the moon to move, there are days I don't move that far off my couch. And the moon's moving that in a year? Yes, it was a lot.
It travels a lot further in the around direction than in the away direction.
Okay, thank you for the reassurance. You just brought me a level of comfort that I really needed.
Yeah. It goes all the way around the Earth in a circle, 250,000 miles radius every month.
Yeah. Yeah.
Right?
No.
So 2 pi times 250,000 per month. It's pretty fast.
Too much for my little phone calculator.
Right?
Too many zeros.
I got a special calculator on my phone.
Oh,
Physicist calculator. Yeah,
the Physicist Calc
I
app
did.
on the Apple iStore.
Yeah, I did.
I love it.
Actually paid like $3.99
Oh my
for it on the App
God.
Store. Yeah, it's a good calculator.
We're learning a lot today about
Wow.
eclipses and about special physicist apps.
Yes, and there are a lot of eclipse-related apps also.
What?
In fact, I have some paper. If anybody wants some, maybe I can get somebody to volunteer to just pass these around, because this has some apps on it that are well recommended by people who really know what they're talking about.
Yeah. More eclipse
Yeah.
resources.
So here's some eclipse resources coming around.
Yeah. I need to do reading because I'm
Okay,
I'm so
we'll
excited.
save one for you to be sure.
I'm too excited. Well, and so you were telling me that you have spoken at other eclipse events. Do you know where some of the events are happening around here in Indianapolis?
Okay, so there will be a lot going on the IUPUI campus. We're going to have several people with telescopes doing projections onto screens.
Oh, that's cool.
So you can observe safely.
Yeah.
And in a large group, we're going to be handing out, we have about 5,000 pairs of eclipse glasses. So we'll be handing those out at multiple locations around campus.
Okay.
There will be a big event in the White River State Park.
Ooh.
And of course, at the IMS, at the Speedway, NASA will be there. The Speedway will be an official NASA viewing site with NASA experts on hand
Yeah.
to describe what's going on.
Yeah, that's going to be so cool.
Yeah, so that's some subset. There are lots of other things going on. A lot of businesses are having things. I think, is Ash and Elm having something?
I don't know if Ash and Elm is having an event the day of the eclipse. I know that they're giving out glasses with a purchase of a 4-pack.
Yes.
So,
Yes, so pick up your 4-pack before you go and get the eclipse glasses.
and then the State Museum is having an event as well. So if you guys want the camaraderie and you don't want to harass your neighbors like I plan on doing,
Right.
you can go find people who are willing observers.
Yes, I will be on the front lawn of the State Museum. And don't get confused. If you look at the State Museum's website, they have 2 different things. The front lawn will be open to the public. They have a paid event inside that's,
Who wants to be inside?
for the hoity-toity among us, but I'm not. I wasn't invited to that. I was invited to do the free thing on the front lawn. So. And I'm a museum member too, so.
Oh, and they didn't put you in the hoity-toity,
No,
but you'll be outside, so you'll get
but I will be outside.
best shot.
Yes.
Yeah, who wants to be inside for an eclipse? Not me.
Well, I'm sure they'll take them outside during the,
Oh, we will let the procession.
but they'll, there's hors d'oeuvres,
Yeah, well, when they get chilly, come back in. No,
Yeah, right.
and if you're going to the paid event, we love you. But we're all just going to be outside shivering because I'm certainly going to forget my coat inside.
Oh, yeah, no, don't forget your coat. It's still early April.
Yeah, see, again, only 7 years in the
Like,
Midwest, I'm learning.
Ever been to the opening day of a baseball season and been
No.
kind of chilly? I have.
Oh,
Could be the same.
yeah.
It's, it's Indiana weather, so it could be in the 80s, but I doubt it.
Yeah.
I think the 50s is more likely. I just hope it's sunny. I don't care how cold it is.
If there's any juju in the world, that if anyone is superstitious, do what you got to do so that we have clear weather and nobody get married. No one's allowed to get married on the day of the eclipse. And I don't know if having your birthday, my mom's birthday is on the eclipse.
Oh,
I
is it
don't know if
really?
that's good or bad. I think
Uh-huh.
it's good. But if that's an omen, I'm hoping that she brings us the good weather.
I certainly hope it's a treat for her. A birthday
Well,
present
she's in
from the
Florida,
universe.
so she won't be able to see it.
Oh,
I know. But I'm going to see it on her behalf, and I'm hoping that her good juju spreads to Indianapolis and we get clear skies. And if not, I love that, the positivity of, you know what, we had this collective experience and we got to be jazzed about it together and disappointed about it together. And you know what? I guess we all just have to make a trip to Australia. Oh,
Yeah.
doesn't that suck?
2026, 27,
27, I think.
2027, I
Yeah.
think, in Australia.
So darn guys, I guess I'll see you in Australia. And with that, come grab an information sheet. I will be grabbing one. Is Citizen Nature Challenge happening early April? Do you want to talk the end of April? Will it be before our next booze? All right, well, so keep an eye out on all of our socials at Indiana Sciences. We talked a little, in the book, they talk a little bit about a citizen science project where they had people in different corner streets in New York timing the eclipse so they could
Yes.
help. If you want to get involved in citizen science and you thought that was really cool, the Citizen Science Nature Challenge is coming up in April, and we'll be asking you guys to catalog all of the flora and fauna of your yards and of the places you are. And it's one of the largest citizen science projects in Indiana. And it's a lot of fun because you just take the picture on your phone and it'll help you identify what it is. You'd be shocked at how much is just in your backyard. And awesome excuse to go explore some of our municipal parks, which are amazing. So with that, I will see you guys next month. We'll be reading This Is Your Mind on Plants, a book, I think it's by Michael Pollock. And a friend of mine is going to be coming. She studies the plant immune system, which I didn't know plants had immune system. I know, isn't she cool? I'm excited. I'm excited to talk to her. And I cannot promise you that we won't talk about psychedelics for like an hour. But, hopefully we manage to weave
Michael
in.
Pollan is famous for that, so.
Yeah, well, so we'll see what we get to beyond that. But I'm excited to talk about it next month, and I'm excited for the eclipse. I hope I see you guys out there. And stay safe out there. We'll see you soon.
All right. Bye, thank you.
Thank you. No, thank you for coming. We really appreciate it. You did quell the existential dread I felt. Reading that the moon is slowly escaping.
She's been around for a long time.
It probably was the eclipse, but we have like 15 plus people on the live stream. Wow. Like the whole time. Yeah. Usually we're in like that 5 to 10. Like we had like 15 to 20 most of the